हुन्छ सर हुन्छ
गरौँ गरौँ सर
ल ल ल ल त्यस्तो केही साथीहरूले इन्फर्म मागे भने भन्नु है ल in our last class we were discussing about oscillation and types of oscillation, and today we are going to discuss about the terms that are used in oscillation. What are the different terms that are used in oscillation? अब यो आज हामी त्यसको बारेमा स्टडी गर्छौं है त एकछिन है यहाँ
यो क्यालेन्डरले झुकायो क्या है आदि साथीहरूलाई त
सर होल्डमा गएको
लिभ नै गर्नुभयो जस्तो हाल त
खोइ अर्को क्लासमा जानुभयो होला क्या त्यहाँ भन्नलाई
होल्ड देखाइरहेछ देखाउनु त फेरि अनुहारमा
फेरिमा त होल्डबाट नि हट्नुभयो
यो सर क्वार्टरमा हो कि घरमा हो यो सरको अलिक त्यो स्लाइड चेन्ज भएको नि अलिक क्लियर देखिन्छ
अघिल्लो क्लासमा भएको नोटहरु छ कसैसँग
सबभन्दा राम्रो चाहिँ त्यो कम्प्युटर सरको हो क्या कम्प्युटर सरमा यस्तो प्रब्लम नै हुँदैन क्या है
एक टाइप गरेको नि ठ्याक्कै टाइममै देखिन्छ
ट्याक्क टाइममा देखिन्थ्यो अनि ब्याकअप पनि थियो सरको त लाइन गए पनि हुन्थ्यो
यो सर पनि अहिले आफ्नो स्क्रिन सेयर गर्दाखेरि त अलि माउस हल्लेको त क्लियरली देखाइदियो अरू सरको त माउस पनि अड्केर
ए छोड्दिएन यार नेटमा लास्ट प्रब्लम हुँदैछ फिजिक्स पढ्नु पर्यो यार अनलाइन त ग्रुपमा पठाऊ है यो अघिल्लो क्लासको नोटहरु
रेकर्ड भइरहेछ है गाइज
सबै आइसक्यो त
हेलो
यस सर
ए यहाँ
हेलो सर
ह्याङ भयो क्या मेरो त चल्दै चलेन यहाँ त्यो भएर डिस्टर्बेन्स आयो ल ठिकै छ अब सुरु गर्छु म ल इन लास्ट क्लास वी आर डिस्कसिङ अबाउट oscillation and types of oscillation, and today we are going to discuss about the different terms that are used in oscillation. तो oscillation को मा युज हुने टर्म्सहरूको बारेमा हामी स्टडी गर्छौँ है आज। यहाँ सेयर भयो होइन कि मेरोमा आज यो के भयो कम्प्युटरमा
स्लाइड केही पनि देखाएको छैन।
हो त नि, यहाँ ह्याङ जस्तो भयो के, त्यो भएर यहाँ समस्या आयो है एकछिन। ल अब हुन्छ होला। ल अब देखिया छ। ल ल ठिक छ। ल अब हेर, today we are going to discuss about the different terms that are used in oscillation. Now, what are the different terms that are used in oscillation? I have already told you that the different terms that are used in oscillation are deforming force, restoring force, elasticity, plasticity, periodic motion, Hooke's law. These are the different terms that are used in oscillation. So I am going to tell you in brief. एकदम छोटो छोटोमा म भन्छु अनि सिम्पल हार्मोनिक मोसन भन्ने टपिक चाहिँ स्टार्ट गर्छु आज है त। ल नाउ व्हाट इज डिफर्मिङ फोर्स? डिफर्मिङ, द मिनिङ अफ डिफर्म इज चेन्ज। द मिनिङ अफ डिफर्म इज चेन्ज। सो अकॉर्डिंग टू द मिनिङ, डिफर्मिङ फोर्स इज दैट फोर्स दैट चेंजेस द शेप और पोजिशन of the body, or a force that changes the shape or position of the body is called deforming force. And the opposite nature of deforming force is called restoring force, and restoring force brings the body to its original shape or position. And the property is elasticity, and the property that brings the body to its original shape or position is called elasticity, right? So another term is elasticity. Elasticity is the property of the body by which the body recovers or regains its original shape or position when the deforming force is removed. That is elasticity. Elasticity is the property of the body by which the body recovers or regains its original shape or position when the deforming force is removed. And the opposite nature of elasticity is the plasticity, in which the body does not show any tendency to recover its original shape or position even though the deforming force is removed. That is called plasticity. तिमीले डिफर्म गर्यो बडीलाई र त्यो डिफर्म गरेको फोर्स छोडिदिँदाखेरि पनि त्यो बडी पूर्ववत अवस्थामा आउने चाहनै गरेन. If the body does not show any tendency to recover its original shape or position even though the deforming force is removed, that is called plasticity. Now, another term that is used in oscillation is periodic motion. By the word periodic, it is that type of motion that repeats itself after a certain interval of time. That is periodic motion. For example, simple harmonic motion is the example of periodic motion. Periodic motion is that motion that repeats itself after a certain interval of time. And it is also called harmonic motion. It is also called harmonic motion. Now, another term is mean position. यो सिम्पल टर्म हो है, तिमीले पहिले पढाएको छौ, यसो हेरेपछि जान्दछौ, मैले जस्ट रिभिजन मात्रै गरेको है। नाउ mean position. Mean position is the equilibrium position of the body. It is the equilibrium position of the body where the body has maximum kinetic energy or minimum potential energy. Where the body has maximum kinetic energy or minimum potential energy is called mean position. Mean position is that position, is that equilibrium position of the body when no force is applied. And at that position, the body has maximum kinetic energy or minimum potential energy. That is mean position. And another term is Hooke's law. What is Hooke's law? About Hooke's law, you have studied in class 11. Hooke's law and its experimental verification. It relates two physical quantities, stress and strain, or it also relates the applied force and extension produced. And it states that within the elastic limit, if the applied force is within the elastic limit, then the extension produced on a body on a wire is directly proportional to the applied force. The extension produced on a wire is directly proportional to the applied force, right? This is the statement of Hooke's law. And if you suppose that in mathematical form, if you suppose that Y be the extension produced on a wire, Y be the extension produced on a wire, and F be the force applied on it, then by Hooke's law, you can write F is proportional to Y. F is directly proportional to Y. And this sign of proportionality is replaced by K. And this K is called spring constant or force constant. Force constant. And as you know, the extension produced is related with strain produced. The extension produced is related with strain, and applied force, that means it relates with stress. So you can stress, or you can state Hooke's law in terms of stress and strain also. In terms of, you can state Hooke's law in terms of stress and strain also. And it states that within the elastic limit, this force is related with stress, and this extension produced is related with Y, strain. So you can state Hooke's law by another way also. That means it states that within the elastic limit, stress is directly proportional to strain. Stress is directly proportional to strain within the elastic limit. Stress is directly proportional to strain within the elastic limit. This is another statement of Hooke's law. Both are same. Both are same. And this sign of proportionality is replaced by some constant, and that constant is called modulus of elasticity. That constant is called modulus of elasticity, and it is denoted by E. It is denoted by E. And you can divide, as you have three types of strain. They are longitudinal strain, volume strain, and shearing strain. So you can have, or you have three types of modulus of elasticity. If you take longitudinal strain, the modulus of elasticity is Young's modulus of elasticity. The modulus of elasticity is Young's modulus of elasticity. And if you take volume strain, the modulus of elasticity is bulk modulus of elasticity, and that is denoted by K. Young's modulus of elasticity is denoted by Y. And another type of modulus of elasticity is modulus of rigidity. And if you are taking shearing strain, then the modulus of elasticity is modulus of rigidity, and that can be represented by eta. These are the different terms that are used in oscillation. They are deforming force that changes the shape or position of the body, restoring force that brings the body to its original shape or position. Number 3, elasticity, that is the property by which the body recovers or regains its original shape or position when the deforming force is removed. Opposing nature of elasticity is plasticity, and another term is periodic motion or harmonic motion that repeats itself after certain interval of time. Another term is mean position, where the body has maximum kinetic energy or minimum potential energy, and that position is also called equilibrium position of the body when no force is applied. And final term we will discuss is about Hooke's law, and Hooke's law states that within the elastic limit, the extension produced on a wire is directly proportional to the applied force, and that can be stated by another way also. You can state Hooke's law by another way also in terms of stress and strain. In terms of stress and strain, it states that within the elastic limit, stress is directly proportional to strain. This is about Hooke's law, and these are the different terms that are used in oscillation. Now, another familiar term and important term for you, for your exam also, is simple harmonic motion. This is the important topic for you. What is simple harmonic motion, or what type of motion is simple harmonic motion? About simple harmonic motion, you have already studied in detail in class 11. And you know what type of motion of the body is simple harmonic motion. There are three conditions. Listen very carefully. There are three conditions for the motion to be simple harmonic. They are, one is motion should be periodic, right? Motion should be periodic. Number 2, the oscillation produced on a body should be directly proportional to the displacement of the body from the mean position. The oscillation produced on a body is directly proportional to the displacement of the body from the mean position. That is second necessary condition. And third necessary condition is the motion should always be directed towards the mean position. If you combine all the requirements for the motion to be simple harmonic, then you can define simple harmonic very easily. You can define simple harmonic motion very easily. I have told you that there are 3 necessary conditions for simple harmonic motion. What are they? Motion should be periodic. 1. Number 2, the oscillation produced on a body is directly proportional to the displacement of the body from the mean position. And number 3, the motion should always be directed towards the mean position. If the motion of a body fulfills all the requirements for simple harmonic motion, then you can say that the motion of that body is simple harmonic motion. So, by combining, you can define simple harmonic motion like this. Simple harmonic motion is a periodic motion, or a periodic motion in which the oscillation produced on a body is directly proportional to the displacement of the body from the mean position. Displacement of the body from the mean position, and the motion is always directed towards the mean position. The motion is always directed towards the mean position. Such type of motion is called simple harmonic motion. यी 3वटै कन्डिसनहरु सेटिस्फाई गर्नु पर्यो. कुरा बुझ्यो? र एक्जाममा सोधेको छ नि, व्हाट इज सिम्पल हार्मोनिक मोशन भन्न आयो भने तिमीले 3टा कन्डिसनहरु, द मोशन अ पिरियोडिक मोशन, that means motion should be periodic, and in which oscillation produced on a body is directly proportional to the displacement of the body from the mean position, and the motion is always directed towards the mean position. Such type of motion of the body is called simple harmonic motion. And in mathematical form, you can state simple harmonic motion like this. Let us see in the screen. If y be the displacement of the body from the mean position and a be the oscillation produced on it, then for simple harmonic motion we must have a is proportional to minus y. A is proportional to minus y, where y is displacement of the body from the mean position, and this negative sign shows the motion of the body is directed towards the mean position, right? अब यदि कुनै बडीको मोसनलाई तिमीले यस्तो फर्ममा एक्सप्रेस गर्न सक्यौ, if you can express the motion of the body in terms of a is proportional to minus y, then you can say that the motion of the body is simple harmonic motion. And you can divide simple harmonic motion or harmonic motion into 2 types. You can divide harmonic motion into 2 types. They are linear simple harmonic motion, in which the body undergoes linear displacement from the mean position, and another type of simple harmonic motion is angular harmonic motion, in which the body undergoes angular displacement from the mean position, right? You can divide simple harmonic motion into 2 types. What are they? One is linear simple harmonic motion, in which the body undergoes linear displacement from the mean position, right? And if the body undergoes angular displacement from the mean position, then the simple harmonic motion or the angular harmonic motion is called angular harmonic motion, or such type of harmonic motion is called angular harmonic motion. In this way, you can divide harmonic motion into 2 types. अब यहाँ हार्मोनिक लिनियर सिम्पल हार्मोनिक मोसनमा के हुन्छ त भन्दाखेरि तिमीले यही डेफिनेसनमा लिनियर भन्ने वर्ड राख्दै जाऊ. राम्रोसँग सुन्नु त. व्हाट इज लिनियर सिम्पल हार्मोनिक मोसन? अ पिरियोडिक मोसन in which the linear oscillation produced on a body is directly proportional to the displacement of the body from the mean position, and the motion is always directed towards the mean position.
So slide change भएको छ.
ए हुन्छ, अहिले हेर्नु पर्दैन. हजुर स्लाइड चेन्ज हुन्छ, अहिले त हेर्नु पर्दैन के, तिमीले यतिकै नै बुझ्छौ. बुझ्ने कुरालाई स्लाइड गरिराख्नु पर्दैन के है. ल लिनियर सिम्पल हार्मोनिक मोसन. इन लिनियर सिम्पल हार्मोनिक मोसन a body undergoes linear displacement from the mean position. So the equation of linear simple harmonic motion will be a is proportional to minus y, where a is linear oscillation and y is linear displacement from the mean position, right? And you know about analogy parameter between linear motion and rotational motion. In rotational motion, the displacement is denoted by theta. So to describe about angular harmonic motion, you should replace this y by theta, and which is called angular displacement, right? And in case of angular harmonic motion, this oscillation is replaced by alpha, which is called angular oscillation. So for angular simple harmonic motion, you can state like this: alpha, alpha is directly proportional to minus theta, where theta is angular displacement of the body from the mean position and alpha is angular oscillation. So you can define angular oscillation, angular simple harmonic motion like this: a periodic motion in which angular displacement produced on a body is directly proportional to the angular oscillation, or angular oscillation produced on a body is directly proportional to the angular displacement of the body from the mean position. And this negative sign shows the motion is always directed towards the mean position. अब तिमीलाई एक्जाममा सोधिराखेको छ, what are the differences between linear simple harmonic motion and angular harmonic motion? अब त्यसमा तिमीले nature of the equation are same. Nature of the equation are same. Nature of the definition is same. But the parameters used in linear and angular simple harmonic motion are different. In case of linear simple harmonic motion, you should use the symbol A for oscillation. But for angular harmonic motion, you should use the symbol alpha, right? And you should say angular oscillation. You should say angular oscillation. And in linear simple harmonic motion, this is linear displacement, and that can be represented by y. But in case of angular harmonic motion, you should represent it by theta, and you should say angular displacement. That is called angular displacement. This is about angular simple harmonic motion. अब म यसको linear simple harmonic motion र यसको characteristics equation derive गर्छु, अनि linear को निकालेपछि angular को पनि त्यही नै हुन्छ है त. अनि linear simple harmonic motion हुने भनेको linear force का कारणले हो. A linear force is responsible, or a force is responsible for linear simple harmonic motion, and which is called restoring force. Which is called restoring force. Which is called restoring force. But for angular simple harmonic motion, you should have restoring torque. Which force, which physical quantity is responsible for angular motion? Angular motion गराउने भनेको कुन फोर्सले हो? रोटेशनल मोशन प्रोड्युस गर्ने भनेको कसले हो? टर्कले हो. कुरा बुझ्यौ? त्यसकारण लिनियर सिम्पल हार्मोनिक मोसनमा तिमीले रिस्टोरिङ फोर्सको कुरा गर्छौ, तर एंगुलर सिम्पल हार्मोनिक मोसनमा रोटेशनल मोशन प्रोड्युस गर्ने फोर्स भनेको टर्क हो. मोमेन्ट अफ फोर्स, टर्क, टर्निङ इफेक्ट अफ फोर्स और rotational effect of force, that is called torque, and that is nothing but that is the product of force and perpendicular distance between the forces, that is torque. So while studying about linear simple harmonic motion, you should start from restoring force, and while studying about angular simple harmonic motion, you should start from restoring torque. That is the difference between them, that is the major difference between them. कुरा बुझ्यौ? त्यसकारण अब सबैले याद गर, लिनियर सिम्पल हार्मोनिक मोसन स्टार्ट गर्दाखेरि रिस्टोरिङ फोर्सबाट स्टार्ट गर्ने हो है त. भने एंगुलर हार्मोनिक मोसन स्टार्ट गर्दा हामी रिस्टोरिङ टर्कबाट स्टार्ट गर्ने. तिमीले लिनियर फोर्समा F = ma हुन्छ नि, ma हुन्छ नि. व्हाट इज इट्स एनालॉजी इक्वेसन इन केस अफ रोटेशनल मोसन? इन रोटेशनल मोसन F इज रिप्लेस्ड बाय टाउ. टाउ mass is replaced by I and acceleration is replaced by alpha. Tau equal to I alpha. Tau equal to I alpha. You should use that formula, right? You should use that formula. अब म 1 by 1 भन्दै जान्छु, तिमीले चाहिँ हेर्दै जाऊ, नबुझे सोध है त. ल, this is about harmonic motion. Now, what is the differential equation of linear simple harmonic motion? अब यो एकदम इम्पोर्टेन्ट छ नि, अघि पढाएको पनि इम्पोर्टेन्ट छ है, र यो झनै बढी इम्पोर्टेन्ट छ. र यसको क्यारेक्टरिस्टिक्स इक्वेसन तिमीले क्लास 11 मै डिराइभ गरिसकेका छौ. अब यहाँ अलिकति फरक तरिकाबाट गर्छु है, डिफरेन्शियल तरिकाबाट. र हेर्दै जाऊ है, डिफरेन्शियल इक्वेसन अफ लिनियर सिम्पल हार्मोनिक मोसन एन्ड इट्स क्यारेक्टरिस्टिक्स इक्वेसन. अब तिमीलाई एक्जाममा भन्छ डिराइभ द डिफरेन्शियल इक्वेसन अफ लिनियर सिम्पल हार्मोनिक मोसन एन्ड डिस्कस अबाउट इट्स क्यारेक्टरिस्टिक्स इक्वेसन. भर्खर मैले तिमीलाई के भने भन्दाखेरि लिनियर सिम्पल हार्मोनिक मोसन भनेको रिस्टोरिङ फोर्सका कारणले हुन्छ. कुरा बुझ्यौ? रिस्टोरिङ फोर्स इज रेस्पोन्सिबल फर linear simple harmonic motion. And you should start from here. ल हेर है सबले, in linear simple harmonic motion, राम्रोसँग सुन्ने सजिलै छ. In linear simple harmonic motion, the restoring force is directly proportional to the linear displacement of the body from the mean position. The linear restoring force is directly proportional to the linear displacement of the body from the mean position. Right? And if you suppose that y be the displacement of the body from the mean position and F restoring is the restoring force applied on it, acting on it, then for linear simple harmonic motion or in linear simple harmonic motion you have F restoring is directly proportional to y. यहाँबाट स्टार्ट गरे, ठीक छ. F restoring is directly proportional to y, right? Restoring force is negative of deforming force. कुरो बुझ्यो? त्यसकारण यो रिस्टोरिङ साइन हटाउनको लागि नि, to remove this restoring term you should write negative sign here. That means you have an equation F equal to minus ky. F equal to minus ky. This is equation 1 and where k is constant and that constant is called force constant. That constant is called force constant. ठीक छ. अब यसको युनिट के भयो त भन्दाखेरि हेर्दा the unit of force constant is k equal to F by y हो नि. F को युनिट चाहिँ न्यूटन भयो, y को युनिट मिटर भयो. न्यूटन per meter is the unit of force constant. Now, what is Newton's second law? Newton's second law is F equal to ma. ठीक छ यो, F equal to ma. And what is acceleration? Acceleration is nothing but it is rate of change of velocity. Rate of change of velocity. And again, what is velocity? Velocity is rate of change of displacement. So you can write acceleration in differential form as d square y by dt square. कुरो बुझ्यो हैन? Acceleration को differential form भनेको d square y by dt square. यो त सबैलाई थाहा छ नै छ. अब हेर त, what is our equation 2? Equation 2 is F equal to m d square y by dt square. This is our equation 2. ठीक छ. अब equation 1 र 2 लाई इक्वेट गर. Now equate equation 1 and 2, or now from equation 1 and 2 you get this formula. हेर त सबले, यहाँ equation 1 भनेको minus ky हो, F equal to equation 2 भनेको F equal to m d square y by dt square. दुईटालाई इक्वेट गर. भनेपछि के आयो त भन्दा m d square y by dt square equal to minus of ky. ठीक छ. अब हेर, d square y by dt square plus यो ky लाई लेफ्ट हैंड साइड में लयो भने k by m y equal to 0. Here this term k by m, here k is force constant, that is constant, and m is constant. Mass of the body is constant, and let us denote this as omega square because it has the dimension of omega. बुझ्यो? यसको डाइमेन्सन र ओमेगा को डाइमेन्सन एउटै हुन्छ. बुझ्यो बुझेन? त्यसकारण this k by m is denoted by omega square and this y is y equal to 0, where omega equal to root under k by m. Here in place of k root under k by m we are writing omega, and that is called angular frequency. That is called angular frequency. And this is the differential equation of linear simple harmonic motion. And you can say, if you can express the motion of the body in terms of d square y by dt square plus omega square y equal to 0, then you can say that the motion of the body is linear simple harmonic motion. Then you can say that the motion of the body is linear simple harmonic motion. अब तिमीलाई कसैले सोध्न सक्छ, what is simple harmonic motion? Derive the differential equation of linear simple harmonic motion भनेर एक्जाममा आयो भने यहाँसम्म लेख्ने. कुरो बुझ्यौ? डेफिनिसन लेख्ने d square y by dt square plus omega square y equal to 0 गर्ने. अब तिमी सबैले सुन, यदि एनालॉगी इक्वेसन तिमीले हेर्छौ भने एंगुलर हार्मोनिक मोसनमा यो y भनेको थीटा हुन्छ, लिनियर मोसनमा y हुन्छ भने एंगुलर मोसनमा के हुन्छ? थीटा हुन्छ. त्यसैले व्हाट विल बी द डिफरेंशियल इक्वेशन अफ एंगुलर सिंपल हार्मोनिक मोशन? द डिफरेंशियल इक्वेशन अफ एंगुलर सिंपल हार्मोनिक मोशन विल बी d square theta by dt square plus omega square theta equal to 0. कुरो बुझ्यौ? d square theta by dt square plus omega square theta equal to 0. That will be the differential equation of angular harmonic motion. अहिले म यो पछि भनौला, अहिले यति कुरा बुझ्यौ. अब यसको मिनिङ के भयो त? यसको ब्युटी के भयो त भन्दाखेरि this equation represents the differential equation of linear simple harmonic motion, And this equation tells us that if we express the motion of the body in terms of d square y by dt square plus omega square y equal to 0, then we can say that the motion of the body is linear simple harmonic motion. Right? Now, what are the differential equation, characteristics equation of linear simple harmonic motion? अब characteristics equation derive गर्ने भनेको के हो त भन्दाखेरि यो इक्वेसन छ नि, यसैबाट तिमीले के गर्ने त भन्दा सिम्पल हार्मोनिक मोसनको डिस्प्लेसमेन्टको इक्वेसन निकाल्ने। कुरा बुझ्यौ? डिस्प्लेसमेन्ट, इक्वेसन अफ डिस्प्लेसमेन्ट, इक्वेसन अफ भेलोसिटी, इक्वेसन अफ एक्सिलरेसन, इक्वेसन अफ टाइम पिरियड, इक्वेसन अफ एक्सिलरेसन, इक्वेसन अफ फ्रिक्वेन्सी एन्ड इक्वेसन अफ फेज। यी सबै टर्महरु हामीले निकाल्ने क्यारेक्टरिस्टिक्स इक्वेसनमा। कुरा बुझ्यौ? र तिमीले क्लास 11 मा सबै निकालिसकेका छ, तर यहाँ हामी अलिकति फरक तरिकाबाट, म्याथमेटिकल वेबाट, डिफरेन्शियल फर्मबाट, डिफरेन्शियल वेबाट निकाल्छौं है त। यही इक्वेसनलाई सल्भ गर्ने हो। नाउ टु डिराइभ द क्यारेक्टरिस्टिक्स इक्वेसन अफ लिनियर सिम्पल हार्मोनिक मोसन, लेट अस solve this equation. Let us solve this equation. For that, let us multiply this equation on both sides by 2 dy by dt. कुरा बुझ्यौ? अब यो इक्वेसनलाई नि दुवैतिर 2 dy by dt भन्ने क्वान्टिटीले मल्टिप्लाई गरेर त के हुन्छ? ल हेर है, सबले स्क्रिन राम्रोसँग हेर्ने। ल हेर, multiplying equation 3, multiplying this equation, or that means equation 3 on both sides by 2 dy by dt we get. ल हेर, यसमा दुवैतिर 2 dy by dt ले मल्टिप्लाई गर के आउँछ त इक्वेसन? 2 dy by dt d square y by dt square plus omega square 2y dy by dt equal to 0. अब हेर्ने है सबले। अब हेर त, यो पुरै टर्म छ नि, यो पुरै टर्म भनेको कसको डेरिभेटिभ हो त भन्दाखेरि हेर, यहाँ मैले यहाँ साइडमा लेखिदिएको छु, डिफरेन्सिएसन अफ d by dt of dy by dt होल स्क्वायर इज 2 dy by dt d square y by dt square. That means if you differentiate dy by dt whole square, then you will get this term, whole term, right? If you differentiate dy by dt whole square, then you will get this whole term. What does it mean? It means that if you integrate this term, differentiation र integration त opposite हुन् नि। यदि यो dy by dt को whole square को differentiate गर्दा यो टर्म आउँछ भने यसको इंटीग्रेशन गर्दा के आउनु पर्छ? dy by dt को whole square आउनु पर्छ। कुरा बुझ्यौ? एउटा कुरा यो। अनि अर्को यो सेकेन्ड टर्म हेर, यो सेकेन्ड टर्म हेर, यो ओमेगा स्क्वायर त कांस्टेंट को कुरा भयो, अहिले हामीलाई चाहिएन। 2y dy by dt यसको यो के को डेरिभेटिभ गर्दा यो आउँछ त भन्दाखेरि हेर त, इफ यु डिफरेन्शिएट y स्क्वायर, if you differentiate y square, then you will get this term 2y dy by dt. What does it mean? It means that if you integrate this term, then you will get only y square. You will get only y square. So let us integrate this equation. अब यो इक्वेसनलाई इंटीग्रेट गर। इंटीग्रेट गर्दा मैले भने यो पुरै इंटीग्रेशन कसरी आउँछ त भन्दाखेरि dy by dt को होल स्क्वायर बाट आउँछ, हैन? This is on integration we get this whole term can be replaced by dy by dt whole square. ठीक छ? Plus omega square is omega square, and this 2y dy by dt can be obtained from d by dt of y square. So the integration of this term will be only y square. So omega square y square equal to some constant of integration c. This is equation 4. अब तिमीले इंटीग्रेशन गर्दा constant of integration राख्ने चलन हुन्छ नि, हो? अब यो c लाई भन्छ हामी constant of integration. Now we should determine the value of constant of integration at first. We should determine the value of constant of integration at first. For that, let us consider a position at which the body reaches at the extreme position. अब भन है, तिमीले कुनै बडीलाई डिस्प्लेस गर्दियौ भने एक्सट्रीम पोजिसनमा पुग्दा के हुन्छ? If the body reaches at the extreme position, then before returning back towards the mean position, the body stops. Okay, न? बडी एक्सट्रीम पोजिसनमा पुग्यो, एक्सट्रीम पोजिसनबाट त्यो फर्केर फेरि मिन पोजिसनमा आउने क्रममा के हुन्छ भन्दा त्यो एकछिन यसो टक्क रोकिन्छ। रोकिनुको अर्थ के हो भन्दाखेरि त्यो ठाउँमा त्यो बडी रोकिनुको अर्थ त्यसको भेलोसिटी 0 हुनु। कुरा बुझ्यौ? To find the value of constant of integration, let us assume that the body is at extreme end, extreme position, and before returning back towards the mean position, the body stops for some time. That means the value of dy by dt, rate of change of displacement. If the body stops, then the rate of change of displacement of the body will be 0. So you can say at extreme position, the displacement of the body is maximum, right? The displacement of the body is maximum. That means y equal to ym, maximum displacement of the body from the mean position. And what is that term called? That is called amplitude of oscillation. That is called amplitude of oscillation. So if you consider that the body is at extreme position, the body has maximum displacement from the mean position, and which is called amplitude, and that amplitude can be represented by ym. कुरा बुझ्यो? त्यो बेला y को भ्यालु केले रिप्रेजेन्ट गर्ने हो? ym ले रिप्रेजेन्ट गर्ने. And at that position, the rate of change of displacement of the body is 0. Let us apply this condition at this equation 4. अब यो condition equation 4 मा apply गरेर त के हुन्छ भन्दाखेरि ल यो टर्म त 0 भयो. This term is 0. ओमेगा स्क्वायर ym स्क्वायर. कुरा बुझ्यो? ओमेगा स्क्वायर ym स्क्वायर इक्वल टु c. कुरा बुझ्यो? भनेपछि द भ्यालु अफ कन्स्टेन्ट अफ इन्टिग्रेसन इज ओमेगा स्क्वायर ym स्क्वायर. बुझ्यो बुझेन? अब यो c को भ्यालु इक्वेसन 4 मा राख त के आउँछ? नाउ पुटिङ द भ्यालु अफ c इन इक्वेसन 4. You will get the formula dy by dt whole square plus omega square y square equal to c भनेको के भयो त भन्दाखेरि ओमेगा स्क्वायर ym स्क्वायर. कुरो बुझ्यौ? ओमेगा स्क्वायर ym स्क्वायर. अब हेर यसलाई एक साइडमा चेन्ज गरेर त dy by dt whole square plus ओमेगा स्क्वायर y स्क्वायर इक्वल टु ओमेगा स्क्वायर ym स्क्वायर. अब हेर्नु dy by dt whole square इक्वल टु यति भयो भने व्हाट इज dy by dt? dy by dt is rate of change of displacement. ठीक छ? ल dy by dt whole square equal to ओमेगा स्क्वायर ym स्क्वायर माइनस ओमेगा स्क्वायर y स्क्वायर. अब दुवैतिर स्क्वायर रुट लिदेऊ त के हुन्छ भन्दाखेरि dy by dt भनेको भेलोसिटी हो, रेट अफ चेन्ज अफ भेलोसिटी हो. v equal to dy by dt equal to omega root under ym square minus y square, because you can take common omega square from here. Omega square is common, ym square minus y square. And this equation represents the velocity of the body moving in simple harmonic motion. तिमीले क्लास 11 मा पढाएको थियौ नि. 11 मा सिम्पल हार्मोनिक मोसन को भेलोसिटी निकाल्ने फर्मुला के निकालेको थियो भन्दा ओमेगा रुट अन्डर आई आर स्क्वायर माइनस वाई स्क्वायर गरेको थियो. आर स्क्वायर माइनस वाई स्क्वायर. त्यहाँ आर भनेको के हो त भन्दा एम्प्लिट्युड थियो, वेयर आर वाज एम्प्लिट्युड. बट हियर इन प्लेस अफ आर वी आर राइटिङ ym, बट द मिनिङ इज सेम. Where the meaning of r was amplitude, here also the meaning of ym is also amplitude, right? So the nature of the formula is same, but the way of derivation is different. The way of derivation is different. This is the expression for velocity of the body moving in SHM. ठीक छ? अब हेर यदि तिमीले बडीलाई mean पोजिसनमा छ भनेर कन्सिडर गर्छौ भने के हुन्छ? If you consider that the body is at mean position, then what is its displacement from the mean position? If the body is at mean position, the value of y will be 0. ठीक छ? The value of y will be 0. If y is 0, then what will be the formula for velocity? ल एकजनाले भन त, what will be the formula for velocity?
Omega ym.
Very good.
Omega ym.
Yes, omega y.